Hello, I'm going to show you today how to do lesson 3.2, which is about rotations. All right, we'll call this a warm-up. It says, convert r sub negative 400 to a rotation with a magnitude in the range of negative 180 to 180. Basically what this means is if you're rotating something 400 degrees, what would be the smaller rotation that would be equivalent to that rotation? So basically, I guess what I'm trying to say is a full rotation is 360 degrees, but then you're going 40 degrees beyond that, okay? And so that's actually the answer right there. It's 40 degrees. Okay. Okay, moving on to the lesson now. I guess if you want to get really technical, just because I'm on record saying this, negative 40 would be the real correct answer. Negative rotation means counterclockwise, positive means clockwise. So that's why they're saying that. Anyway, but it's not important. Let's move on. So example 1 is about a fox. And it says, a fox has a field of vision of 85 degrees. How far must a fox turn its head to see something directly behind it? So I'm going to draw myself a fox. Here's the nose and the whiskers and the ears and the other whiskers. And it's got 2 eyes and a nose. And there's my fox, okay? And it's got a field of vision of 85 degrees. So see, its eyeballs, it can see everything in an 85 degree range. Now let's say there's a little bunny rabbit back here, okay, directly behind it. So here's my bunny, okay. Here comes Peter Cottontail. Wow, it's a big tail. Oh well. There's my bunny right behind it. And how far does that fox have to turn its head in order to see the rabbit? Well, let's just think about this. Straight forward to here, this right here, that would be half of 85 degrees. Half of 85 is 42 and a half, 42.5. Now from here to here is 180 because that's a straight line. That means that this distance must be 180 minus 42.5. And therefore, the fox will have to turn its head 137.5 degrees, just like it is in that picture, in order to see that little bunny rabbit, okay? That's a beautiful fox, by the way, wow. Okay, now our lesson takes somewhat of a musical twist, okay? It says, given the C major chord at right, find the notes of the D sharp major chord. Okay, well, there's all the notes, and it's showing the notes of the C major chord as C, E, and G. It says, what is the magnitude? Oh, let's not do that one yet. Let's actually find the notes first. Well, since this is the C chord, and it wants us to show the D sharp major chord, we're going to have to take this dot and rotate it around the circle 1, 2, 3 hops. Now this circle has 12 total notes on it. There are 12 notes. If you believe it or not, all of music is only 12 notes. Kind of amazing. So since there's only 12 notes and a circle has 360 degrees, Well, let's not worry about that yet. Let me actually just finish going over this example. So the C will have to go 1, 2, 3 hops clockwise to change to a D sharp, okay? Now, if the C has to go 3 hops clockwise, so does every other note in the chord. The other 2 notes are also going to go 3 hops clockwise. So that means E will become G, and G will become A sharp. So this note of the chord hopped over to this, and this note in the chord hopped over to that. Okay, so there is the D sharp major chord right there. Right? Now it says, what is the magnitude of rotation in the previous example? This is what I started to get at. Since a circle is 360 degrees, and the circle is divided into 12 sections, each section must be 30 degrees. So each hop is a 30-degree hop. That means 3 hops would be 90 degrees. So that is a 90-degree rotation. So if you can wrap your mind around this, music is actually very geometric. Fascinating. Okay, the next one, it says, given the A minor chord, notice that this triangle has a slightly different shape than the one up here. That's because this is a minor chord and the last one was a major chord. They're not actually congruent triangles, I don't think. Let me think about this one too. Maybe they are actually. Well, they actually are congruent, but anyway, minor chords are slightly different than major chords. So that's beside the point. Okay, so given the A minor chord shown at the right, give the notes of the G sharp minor chord. So now we need to use this circle because this is a minor chord and this one is a major chord. So we actually need to make sure to use this circle. We cannot use this circle to figure this one out. So anyway, okay, G sharp minor. So this is A minor. Well, the bass note right here needs to go 1 to the left, 1 counterclockwise. So G sharp is going to be the first note of this chord. The E will have to go 1 space this way to D sharp. And the note C will have to go 1 space this way to B. There you go. That's your G sharp minor chord. There's only one more example in this lesson, and it's about tennis. So shout out to all you tennis players. I hope you really enjoy this. This goes out to you. Refer to this quotation by tennis player Maria Sharapova after she won the U.S. Open in 2006. I figured I lost the last 4 times against Justine Henin, so I thought I would just flip everything 360 degrees and do the total opposite. What do you think she meant to say? Explain your answer. Maria, if you flip things 360 degrees, you're actually going in a complete circle and you start and you end up exactly where you started. So I think what you meant to say was half of 360. You know what I mean? Like if you were facing this way, you end up doing the opposite thing. I think that's what you meant to say. So I think what she meant to say is 180 degrees. 360 divided by 2. Now I just explained my answer to you using my voice, but if you'd like to write that down, you can. I don't care if you do, though. I don't care what you do. But I do care. I just hope you have a great day. That's what I care about, all right? Now, I'm going to end this video. I hope. Goodbye.